Properties of multiplication. In the third grade, the students do not have to memorize each of the properties' names. They just have to understand the concept behind each property. So the first property is the property of 0, which says anything times 0 is 0. 3 times 0 equals 0. That can be reread or rewritten as 3 zeros. 0 plus 0 plus 0, which is still 0. And 0 times 3 is 0, which can be read as 0 threes. No threes, that's going to be 0 also. The identity property says that anything times 1 is itself. So if we have 5 times 1, that equals 5. And that's the same thing as 5 ones, 1, 1, 1, 1, 1, which equals 5. Or 1 times 5 also equals 5, because this can be rewrite as 1, 5. And next is the commutative property, and it just says that multiplication can be done in any order, and the product or the answer will remain the same. So in the first example, we have 3 times 2, which can be written as 2 plus 2 plus 2, is the same thing as 2 times 3, 3 plus 3. They both equal 6. It's the same two numbers, it's just in a different order. This applies even if you have 3, 4, 5, doesn't matter how many numbers. If you have the same three numbers, so 6, 2, 3, 3, 2, 6, 3, 6, 2, even though they're in a different order, the answer is still going to be the same. You can see this one's 12 times 3 is 36. This one's 6 times 6 is 36. This one's 18 times 2 is 36. All right, next is the associative property, and it just says that multiplication can be grouped in any order and still have the same product. So the grouping is the important part with the associative property. I actually kept the numbers in the same order, 2, 3, 4, 2, 3, 4. But we put the parentheses around the 2 and the 3 in the first one, and in the second we put around the 3 and the 4. In math, you have to do the parentheses first. So in this one, we'd have to do the 2 times 3 first, which is 6. Multiply that by 4, and you get 24. In this scenario, we have to do the parentheses first. So we're going to start with the 3 times 4, which is 12. And then times it by the 2, you still get 24. So it can be grouped in any order, any way you want. All right, decomposing numbers with multiplication is the way that we have decided to present the distributive property. And it's just, we tell the students they can break it apart any way they want to. So if we have 7 times 8, hopefully by the end of the unit and the end of the year, students will know that immediately without having to decompose it. But if they are stuck on a particular problem and they know how to decompose the numbers, then they can break it apart any way they want and still find the answer. So 7 times 8 is 7 eighths. So we have 7 eighths. 1, 2, 3, 4, 5, 6, 7 of them. You can split them up any way you want to. A lot of students will split them up like this because they know what 2 eighths equals and they know what 1 eighth equals. So they'll say 2 eighths, 2 more eighths, 2 more eighths, and 1 eighth. And if you add the 16 and 16, that's 32. 16 eighths, 24, and you add them together and you get 56. Just to show you that 7 times 8 can be decomposed a different way, still have 7 eighths, but this time I'm splitting it into 5 eighths, so you're taking 5 of the eighths of the ones, and 2 eighths. And 5 eighths equals 40, 2 eighths equals 16, that's 46. This is another good one because students are pretty good with their 5s and 10s as well. Last example, 12 sixes. Instead of writing out all 12 sixes, when students really understand the concept of this, they can just break up one of the numbers. So instead of doing 12 sixes, we'll just break the 12 into 10 and 2. So we'll do 10 sixes plus 2 more sixes, which is still 12 sixes total. That's 60 plus 12, which equals 72.